Welcome to Science Excellence. In this video, we will do the rest of the questions of the paper A. So let's get started. So the question number 10 is, the figure above shows shows part of the graph of the curve with equation f of x equals to cos x over 3 minus sin x, and x belongs to R. So you have to use the differentiation to show that f of x between these two values. So we should, because we have to use the differentiation, so we should apply the derivative on this fraction. So you can see this is the fraction of cos x over 3 minus sin x. So if we have a fractional equation, then and you have to differentiate it, we should apply the quotient rule on it. Like, let's say if you have g of x equals to u of x over v of x, then we have to apply the quotient rule to get the derivative of this function. So the quotient rule is the square of the denominator as it is, then derivative of the numerator minus numerator as it is, derivative of the denominator. So this is the formula we're going to apply to get the derivative of this function. So if you apply this formula, then f prime of x will be the square of the denominator, then denominator as it is, times the square of the numerator, which is cos. So derivative of cos is minus sine, then minus due to the formula, then numerator as it is, and the derivative of the denominator. So derivative of 3 is 0, and derivative of sine is cos, so it should be minus cos because minus sine. So derivative of minus sine is minus cos. So now if you do the term by term multiplication over here, so it will be minus 3 sin x minus plus sine square x, and minus plus over here cos square x over 3 minus sin x whole square. So now if you apply the identity, trigonometric identity, sin square x plus cos square x equals to 1. So you can replace this with 1. So we're left with minus 3 sin x plus 1 over 3 minus sin x whole square. So if you put the derivative, first derivative equals to 0 for the stationary point. So if this fraction, if the derivative equals to 0, that means this fraction equals to 0. And if the fraction is 0, minus 3 sin x plus 1 over 3 minus sin x square equals to 0. If the fraction is equals to 0, that means the numerator should be 0. If you set this denominator as 0, then the function will be undefined, so the numerator should be 0. So 3 sin x plus 1 equals to 0. So if you work out this for sin x, if you take away minus 1, if you take away 1 from both sides, so it will be minus 3 times sin x equals to minus 1, and divide by minus 3 on both sides, so sin x will be 1 over 3. This is our stationary value. Now since if you see the f of x, in f of x we have cos x and sin x, and we got the value of sin x, which is 1 over 3, and we can use a trig identity to get the value of cos x, and then we can sub the values back over here to solve this function. So then we can work out the values of f of x, and we will get this result. Okay, so we got sin x equals to 1 over 3, and we know that sin square x plus cos square x equals to 1. So if you make the cos square x as a subject, so it will be cos square x equals to 1 minus sin square x. And if you apply the root on both sides, so cos x will be root of 1 minus sin square x. And when you apply the root, you'll get positive and negative, both answers. So the value of sin x, which is 1 over 3, you can sub over here. Then it will be cos x equals to plus minus root of 1 minus 1 over 3 square. And it will be plus minus 1 minus 1 over 9 when you apply the square. So if you figure out this on the calculator, it will be 8 over 9. So if you typeset this square root of 8 over 9 on the calculator, you will end up with 2 over 3 root 2, which is the value of cos x. So we got the two different values of cos x and the one value of sin x. So we can sub these values into the given function, and the given function was f of x equals to cos x over 3 minus sin x. Okay, so if we got the value of sin x as 1 over 3 and the cos x plus minus 2 over 3 root 2. So for positive value of cos, 2 over 3 root 2 over 3 minus 1 over 3. So if you simplify, if you type this fraction into the calculator, you will end up with 1 over 4 root 2. And we can get one more value by using the negative value of cos over here. So it will be minus 2 over 3 root 2 over if you sub the negative value of cos, it will be minus 2 over 3 root 2 divided by 1 minus the value of sin is remains same, 1 over 3. And if you typeset this on the calculator, you will end up with negative value, which is minus 1 over 4 root 2. So it means our f of x is between minus 1 over 4 root 2 f of x and f of x is less than or equals to 1 over 4 root 2. So this is the result we have to show. Okay, so the next question is, water is leaking out of a hole at the bottom of a tank. Let the height of the water in the tank be y centimeter at time t minutes. At any given time after the leaking started, the height of the water in the tank is decreasing at the rate proportional to the cube root of the height of the water in the tank. So when t equals to 0, y equals to 125, and when t equals to 0, y is 64, these two conditions are given. And by forming and solving differential equation, we need to find the value of y when t is this. So this statement is very important over here. At any given time after the leaking started, the height of the water in the tank is decreasing at a rate proportional to the cube root of the height of the water in the tank. So height is represented by y in this question at time, and they represent the time by t. So we should have the differential equation according to this statement, because if we consider dy over dt, this is the rate of change. Derivative is if you write dy over dt, that means rate of change of y with respect to t. So y is the height, so rate of change of height with respect to t equals to minus k times the cube root of the height according to the given statement. Because it is decreasing, so we should consider the negative constant with it, and we should apply the cube root on the height because it is given that the cube root of the height. So this should be the differential equation according to the given statement. Now since we need to solve this differential equation, so we should apply the separation of the variable first. So if we take dy on the same side, and if you take this divide by y power 1 over 3 on both sides, we'll get 1 over y power 1 over 3 on the left hand side. And if you take this dt to the right, it will be minus k times dt. And if we take this y up now, it will be y power minus 1 over 3 dy equals to minus k dt. Now the variables are separated, we can apply the integral on both sides. So if you apply the integration on both sides, so if you apply the integral on both sides, the integral of y power minus 1 over 3 dy equals to minus k integral dt. So you know the basic integration, or this is the basic function. So we should if you apply the power rule, we need to add 1 to the power and we have to divide by the same power. So it's minus 1 over 3, so if you add 1 to the power, it will be 2 over 3 divided by 2 over 3 equals to minus k times derivative of integral of dt is t plus constant integration. So if we further simplify, if you take this up, it will be 3 over 2 times y to the power 2 over 3 equals to minus k t plus c. So since minus k and c are the constants, so you can replace this minus k with any other constant. Let's say minus k equals to a and c equals to b. We can change, then we can give any name to the constant, because minus k is a constant, so we can replace by a, and it's easy to work out, so we can replace with a. So sorry about that, we should times by 2 over 3 on both sides to get rid from this constant on this side. So if you times by 2 over 3 on both sides, then this 3 cancel out, 2 and 2 cancel out, you're left with y equals to, sorry, y power 2 over 3 equals to minus 2 over 3 kt plus 2 over 3 c. So this is the simplest form of the equation. Now minus 2 over 3 k is the constant, so we can give any name for the simplification to this constant, let's say a, and 2 over 3 times c will be b. So we give the name the different name to these constants to make the easy equation, and then we will have y power 2 over 3 equals to a t plus c, plus b. Now we can apply the given conditions on from the question, and you know the first condition is when t equals to 0, y is 125, and when t equals to 3, y is 64. So when t is 0, y is 125. So if you put these values in, so 125 to the power 2 over 3, a times t is already 0 plus b. So 125 to the power 2 over 3, so if you apply the cube root on it, it will be 5, and 5 power 2 is 25. So if you set the left hand side on the calculator, it will be 25, and the 25, a times 0 is 0, so p is 25. So if we use the other condition from the question, which is when t is 3, y is 64. When t is 3, y is 64. So if you sub these conditions here again, then you need to replace your y with 64 to the power 2 over 3, and a times 3 plus b we already work out, and we can replace our b with the value of b, which is 25. So So the if you apply this to a power 2 over 3 on 64, it will be 16, and 16 equals to 3a plus 25. Then if you take 25 on the left, it will be 16 minus 25 equals to 3a, and 16 minus 25 is minus 9 equals to 3a. If you divide by 3 on both sides, a will be minus 3, and we can sub these values of a and b back into the function. Then y, this function will be y power 2 over 3 equals to, value of a is minus 3, we can sub over here, which is minus 3t, and the value of b was 25. So this is the function with known constants, right? So now we can put the value of the t, the last condition, to get the value of y, this condition. By forming a solving differential equation, find the value of y when t is 7 whole 7 over 12. So we can sub the value of t here to get the value of y. So y is 2 over 3 minus 3 times the value of t is 7 whole 7 over 12 plus 25. So you can typeset this on the calculator. You will end up with y power 2 over 3. If you solve this on the calculator, you will end up with 9 over 4. Now since we need the value of y, and then we have y to the power 2 over 3, so if you apply the reciprocal power of this power, like power 3 over 2 on both sides, so this 3 cancel out, 2 cancels out, left with y, and this 9 over 4 to the power 3 over 2. So if you work out like this, apply the root on the number fraction first and keep your cube outside. So the root of 9 is 3 and the root of 4 is 2 whole power 3. So 3 power 3 is 27 and 2 power 3 is 8. So 27 over 8 is the answer, which is the value of y. Okay, the next question is, calculate the two missing values of y in the following table. So you can see against the value of x 0.3 and the 0.4, we have to work out the value of y. So y is a function which is x square over 2x. So we just need to replace our x with 0.3 to get the value of y over here. So is y equals to 0.3 whole square over 2 times 0.3 plus 1, and if we typeset this thing in the calculator, we should end up with 9 over 160. So over here we should have 9 over 160. And for the next value, we need to place in this function, we need to place x with 0.4. So y will be 0.4 square over 2 times 0.4 plus 1. So if you typeset again in the calculator, we should end up with 4 over 45. So this was the part A. It was very easy. Now the part B is use the trapezium rule with all the values from the completed table of part A to find an estimate correct to 4 significant figures for the following integral. So we have to use the trapezium rule. That means we have to follow the formula for the trapezium rule, and the formula is area equals to h over 2 y0 plus 2 times y1 plus y2 plus up to so on yn minus 1 plus yn. So in simple words we can say the step size, or the h is the h you can say is the step size or the width of each trapezium divided by 2 over times by the first value, which is y naught, first value, and the last value, and at the middle 2 times by the rest of the values. So this is the actually formula to get to solve this integral, or to get the area under the curve. Okay, so since we have to solve this integral by using the trapezium rule, so if you consider the integral 0 to half x square over 2x plus 1 dx, and we know against this function we have the table over here, and the first value over here should be this value should be y0, this is y1, y2, y3, y4 and y5, and we can see the step size between the values of x is 0.1. the values are increasing by 0.1, so h is 0.1. so we need to sub these values into the formula to get the integral. Since the step size is 0.1 over 2, and the first value from the table, first value of y0 means y0, which is 0, plus the last value is y5 actually, which is 1 over 8, and plus we need to consider 2 times the rest of the values at the middle. So 2 times this y1, y2, y3 and y4, so it will be 2 times 1 over 120 plus 1 over 35 plus 9 over 160 plus 4 over 45. so the middle values we should times by 2. so if you typeset the whole thing in the calculator in one go, we'll get the answer, which is 0.02445, up to 4 significant figures. Okay, so the next part is use the substitution u equals to 2x plus 1 to find an exact simplified value for the same integral. Now we need to use this substitution u equals to 2x plus 1 to solve this integral again for the next part C. So the given integral is integral 0 to half x square over 2x plus 1 dx, and the substitution we have to use is u equals to 2x plus 1. So it means in this integral we have to replace the values of x by u. Each and every x value we need to replace with u. So since you can see here in the integral we have x square, 2x plus 1 we can replace with u, and we have dx, so we need to replace our dx with the du. So first, if you apply the differential derivative on both sides, so du over dx will be 2, and if you take your dx on the other side, it will be du equals to 2 dx, and since we have to make the dx as a subject, divide by 2 on both sides, so 1 over 2 du equals to dx. So this will be the value of dx. Now from here again, since we need the value of x square, if you make the x subject from here, it will be u minus 1 equals to 2x, and divide by 2 on both sides, it will be u minus 1 over 2 equals to x. Since we need the value of x square, so if you apply the square on both sides, it will be u minus 1 over 2 whole square equals to x square. So if you apply the square on this fraction, it will be u square plus 1 minus 2u, and over 2 square is 4 equals to x square. I applied the binomial expansion, otherwise you can consider u minus 1 twice and you can do the term by term multiplication. So this is the value of x square. So we got the value of x square, we got the value of dx, and this 2x plus 1 we can replace with this u. Now we have to switch the limits as well, because the limits are with respect to x and we need to the limits for u. So since we set u equals to 2x plus 1 and the lower limit of x is 0, so when x is 0, if you put x equals to 0 here, u will be 2 times 0 plus 1, so u is 2. So when x is 0, u is 2. Now the other limit of x is half, so when x is half, x is 1 over 2, so you need to place your x with 1 over 2 over here, so 2 times half plus 1, so 2 times half is 1, so 1 plus 1 is 2, so u is 2. So when x is half, u is 2. Sorry, over here 2 times 0 is 0 plus 1 is 1. Yeah, u is 1 when x is 0 and u is 2 when x is half. So the new integral should be, since when x is 0 u is 1, so it should be 1, and when x is half u is 2, so the upper limit should be 2. Now the x square I can replace with u square plus 1 minus 2u over 4, and dx we can replace with 1 over 2 du from here, and divide by 2x plus 1, this thing we can replace with u. So it's 2 times 4, if you time these two, 2 times 4 is 8, so 1 over 8 we can take out, you're left with 1 over integral 1 to 2 u square plus 1 minus 2u divided by this u du. So we can split our LCM, which is u, so integral the limits 1 to 2. If you split the LCM, it will be u square over u plus 1 over u minus 2u over u du. So if you further simplify this, it will be 1 over 8, limit 1 to 2, u square divided by u is u minus plus 1 over u minus u, and u cancel out, so you're left with minus 2 du. So if you apply the integral now, it will be 1 over 8 u square over 2. When you apply the integral on u, it will be u square over 2 plus 1 over u. So you know the integral of 1 over x is ln of x, so it will be ln of u minus 2u, and the limits 1 to 2. Now we need to sub the limits in, and when we put the limits, keep 1 over 8 outside, so the upper limit will be 2 square over 2 plus ln of 2 minus 2 times 2. This is our upper limit, minus lower limit is 1, so it's when you put the lower limit on it, now it will be 1 over 2, because when you replace your u square with 1, so it's 1 over 2 plus ln of 1, which is 0, minus 2 times 1, which is minus 2. So now it will be 1 over 8, 2 square is 4, 4 divided by 2 is 2 plus ln of 2, and this is 2 times 2 is 4 minus 4 minus half, positive half minus 2 will be minus 3 over 2. Okay, so now if we simplify this, it will be 1 over 8, positive 2 minus 4 will be minus 2 plus ln of 2 plus 3 over 2. So if you make the same denominator for these two constants, this and this, you can times by 2 up and down again to make the same denominator. So it's 1 over 8 minus 4 over 2 plus 3 over 2 plus ln of 2 after. Now we can solve these two constants together. It will be 1 over 8, and the both the fractions have the same denominator, so minus 4 plus 3 will be minus 1 over 2 plus ln of 2. So this is the answer for the part C. Okay, now the part D is hence deduce by referring to part B and C the approximate value of ln of 2 correct to two significant figures. So we need to work out the value of ln of 2 by using the part B and C. Okay, so from part B, we work out the value of the integral by using trapezium rule. We work out the value of this integral, which is approximately equals to 0.02445. And from part C, we work out the value of the integral by using substitution method, which is 1/8 ln of 2 minus half. Okay, so now from part B and C, since the left hand sides are equal, so we can equate the right hand sides. So it will be 1/8 ln of 2 minus half, which is equals to approximately equals to 0.02445. So if you times by 8 on both sides to get rid from 8 on this side, so it will be ln of 2 minus half approximately equals to this number times by 8. So if we times this number by 8, it will be 0.1956, and if you add half on both sides to get the value of ln of 2, so ln of 2 equals to 0.1956 plus half. So if you add half in it, it will be equals to 0.6956, and then ln of 2 will be approximately equals to 0.70 to two significant figure as required. Okay, so the last question of this paper is solve the following trigonometric identity, which is cosec 4 theta minus cotangent 4 theta equals to 2/3 plus square root of 3 cot theta, and the theta is between 0 to 2 pi. So we have to solve this on the domain 0 to 2 pi. So if we consider cosec 4 theta minus cot 4 theta equals to 2/3 plus root 3 cot theta, and on the left hand side we can write this as cosec square theta whole square minus cot square theta whole square equals to 2/3 plus root 3 cot theta. Then you can see on the left hand side we have the difference of the squares, so we can apply the formula, which is a minus b times a plus b. We already learned this formula in GCSE, and we can keep the right hand side as it is, 2/3 plus root 3 cot theta. Now if we can use this identity, 1 plus cot square theta equals to cosec square theta, and if you take your cot square theta to the right, then 1 equals to cosec square theta minus cot square theta. So we can use this result over here. We can replace our cosec square minus cot square with 1, so this will turn into 1. We're left with cosec square plus cot square theta equals to 2/3 plus root 3 cot theta. Now we can use the same identity again to replace our cosec square with 1 plus cot square over here to get the whole equation in terms of chord, because this is chord square, this is chord, so we can replace this cosec square with chord square. So cosec square is 1 plus chord square, so you can replace this cosec square with 1 plus chord square theta plus chord square theta equals to 2 over 3 plus root 3 cot theta. So then it will be cot square plus cot square is 2 cot square theta plus 1 equals to 2 over 3 plus root 3 cot theta. Now if you times by 3 throughout to get the rate from this fraction, so it will be 3 times 2 is 6 cot square theta plus 3 equals to 2 plus 3 root 3 cot theta. Now if we take all the values on the one side, if you take this expression to the left, it will be 6 times cot square theta minus 3 root 3 cot theta and plus 3 as it is on the left hand side. If you take this 2 to the left, will be minus 2 equals to 0. So we will end up with 6 cot square theta minus 3 root 3 cot theta. Positive 3 minus 2 is plus 1 equals to 0. So we can see this is the quadratic in chord. So we can typeset this thing quadratic into the calculator to get the factors, the roots, the solution of this equation. So the roots will be cot theta equals to root 3 over 3. If you work on the calculator, the other root, since it's quadratic, we should have 2 roots, so other root is root 3 over 6. We can still simplify this. If you times by root 3 up and down, then cot theta will be root 3 times root 3 is 3, and this will be 3 over root 3, so 3 and 3 cancel out, we're left with 1 over root 3. So since it's easy to solve, work out the values of theta if you switch this cotangent into tan, so tan theta should be the reciprocal of this fraction, which is root 3 over 1, so it's actually root 3. So if you do the same thing over here, so then tan theta from here should be 6 over root 3. Okay, so again we can simplify this. If you times by root 3 up and down, it will be 6 root 3 over root 3 times root 3 is 3, so 6 divided by 3 is 2. So finally the other value of the tan theta can be written as 2 root 3. Okay, now it's time to scan this tan on the domain 0 to 2 pi. So our domain is 0 to 2 pi, and we got tan theta equals to root 3, the first one value, tan theta equals to square root 3. And if you apply the tan inverse on this value, tan inverse of root 3 will be pi by 3, and we can write plus minus and pi, because the period of the tan is pi, where n is an integer, can be 0, 1, 2, 3 and so on, positive integer. And on the other side, if you do tan inverse, since we have tan theta over here equals to 2 root 3, so if you apply tan inverse on it, so tan inverse of 2 root 3, if you work on this on the calculator, we will have 1.2897 radians. Yeah, we need to keep in our mind, we should set our calculator onto the radians, because our domain is in radians 0 to 2 pi. Again over here we can write plus minus and pi, and where n is 0, 1, 2, 3 and so on. So since pi is the periods, we can add or take away n pi to get the other values. After the period will get the same. So now since our tan is positive, the values of tan is positive here and it was positive here as well, So if you consider the quadrants, so in first quadrant all the trig functions are positive, sine positive, tan positive and cos positive. So the tan is positive in first quadrant here, in third quadrant here. So when you put n equals to 0 in this function, you'll get the value in the first quadrant, which is pi by 3. And when you put n equals to 1 over here, when you put n equals to 0 in this one, then theta will be pi by 3 plus 0 times pi is 0, so the first value is pi by 3. And if you put n equals to 1 and consider theta equals to pi by 3 plus n pi, because our domain is positive, so there is no need to consider the negative, because our domain is from 0 to 2 pi, so there is no need to consider a negative n pi. So consider plus n pi and replace your n with 1 in it, then theta will be pi by 3 plus pi. And if you simplify this, it will be 3 plus 1 is 4 pi by 3, which is the value over here in the third quadrant. So now similarly, if you walk out the other side is again the value of the other value of the tan is again positive, so we should have one answer in the first quadrant and the other answer in third quadrant. So if you continue with this one, then theta is 1.2897. when you put n equals to 0 in it, you'll get the one value of theta, which is this one. And again, if you consider theta as a reference angle, which is 1.2897 plus n pi, and you put n equals to 1, that means pi plus some angle, again you are in third quadrant, so we'll get the other value according to this. So it's 1.2897 when you put n equals to 1 in it plus pi, so you need to add pi in it, which is 3 point something. So if you add these two on the calculator, it will be 4.43 something, so other value of theta. So that's it for now. See you soon on the next video with the next paper B of the same series. Thank you for watching.